So hello guys, today we are going to do a leetcode question that goes by the name single number. Yes, single number. The question number is 136 and it's an easy question. Okay, so what you are given is you are given a like abstract topic single number. What does it mean? Okay, so we'll first try to read the problem statement, then we'll go into the solution. Okay, given a non-empty array of integer norms, every element appeared twice except for once. Find that single one. Given a non-empty array of integers norms, every element appears twice except for one. So it is saying that in the array, basically, you are given some array, and you will consider that you will just see that every element in the array will appear twice. Like this 2 appears twice, this 3 appears twice, but there will be one single element that will appear only once. That will appear only once. So you have to get this element. You have to get this element. Okay, get this element. The question might seem simple to you because like the straight approach can directly come to our mind, but there is something given. You must implement a solution with linear runtime complexity and uses only constant extra space. Okay, so many of you might be thinking of a solution that I'm going to tell, but the follow-up question is a little difficult. Like you must implement a solution with a linear time complexity and uses only constant extra space. Okay, so how can we do that? First we'll see the brute force solution. What we can do is, then we'll try to see what the question says. Okay, so as you now know that we are dealing with, like if I am saying that every element appears twice and one element appears once, appears twice, and one element, every element appears twice and only one element appears once. Okay, so now I know that I am talking about frequencies because if I have to know that whether an element appears twice or not, or it appears once, I have to talk about frequencies. I have to talk about frequencies. Okay. Okay. So what I can do is I can simply make a map. I can simply make a map and I can store all of these elements. I can store all of these elements and then I can simply check whose frequency is equal to 1. Whose frequency is equal to 1. Okay, and the element whose frequency is equal to 1, that is my answer. I'll just show you. If I see the same test case 2 2 3 3 1 and this is my map. This is my map. Okay, this is my map. So what I'll do is basically I'll just store each of the element in the map. So I'll start from here, this 2. Okay, I'll store 2 with its frequency. Okay, 2 occurs one time. I'll move my pointer moves here. 2 is occurring again, so I'll increase its frequency. Okay, I'll come to 3. Is 3 present in my map? No, I'll increase its frequency. It's present with the frequency 0, so I'll increase its frequency. Okay, I'll come to this point. I'll increase its frequency. 3 becomes 2. I'll again increase its frequency. It comes to the pointer I. It comes to the position I. It comes to the last position, and the element is 1. Does 1 appear before this? No. So 1 is covering with the frequency 1. Okay. So now I have a map. I have iterated through all the elements. Now I'll simply check what element has a frequency of 1. Okay. I'll come here. Is it has a frequency of 1? Is it having a frequency of 1? No. I'll just move forward. Is it having a frequency of 1? No. Is it having a frequency of 1? Yes. And this is the point I return. Okay, so I will be returning 1. But I am simply doing what? I am simply storing all of the elements in the map. And the element that has a frequency of 1, I'll simply return it. Okay. Okay. So I'll just take one test case 4 1 2 1 2 4 1 2 1 2 4 1 2 1 2. Okay, this will be my map. I will be storing frequencies. So 4 occurs one time, 1 occurs 2 times, and 2 occurs 2 times. Okay, I'll just simply iterate through the map to check whose frequency is 1. Okay, I got the first element as my frequency 1. So I'll simply return this element. I'll just simply return 4. Is 4 is my answer? Yes, 4 is my answer. Okay, so what I'll do is I'll simply store the frequencies of all the elements in the map, and check whose frequency is equal to 1. And I'll simply return that element. Okay. So this was my brute force solution. What is the time complexity? As I'm using, like, iterating only once for this, I'm iterating once for this, and once for the map. So my frequency becomes O of 2 into n, O of 2 into n. Okay. And what is my space complexity? This is my time complexity. What is my space complexity? Am I using any extra space? Yes, of the map. Okay. So what is my space complexity? O of n. So I have an algorithm that runs in O of 2 n time and O of n space. O of n space. It is kind of optimal, but we are said that we have to implement a solution with linear time complexity and only using constant extra space. Okay, so if you carefully observe what we are given with an array, and we are said that all the elements appear twice. All the elements appear twice. So if you carefully observe one thing, like if you come on the bitwise operations, okay, as all the elements appear twice, that is the bitwise, like binary would also be identical. So this 2 would be represented as 0010, and this 2 would be represented as 0010. Okay, can I have a similarity, like when all the numbers come, can I just XOR them? Can I use the XOR operation? Okay, so what I'll get is 0000. So all the digits will be 0, because we know that if we see the XOR table, these are my input symbols and this is my output. So 0 becomes 0, 1 becomes 1, 0 becomes 1, and 1 becomes 0. Okay, so I can see that whenever there are same elements, the answer is 0. The answer is 0. So I can use this formula, I can use this ideology, or I can use this formula. I can use this to find my answer, because I know that every element is appearing twice. So, and they would contain the bits at the same position, because if I would take the binary of 2, 0010, and I would take the binary of 2 again, it would be same, right? So elements would be, so ones would be appearing at the same position, 0 would be appearing at the same position, so the binary representation would be exactly equal. So the elements would be resulting in overall 0. If you can see in this test case also, 3 becomes 0011, and this 3 becomes 0011. If I just XOR it, so it will become 1 becomes 0, 1 becomes 0, 0 becomes 0, 0 becomes 0. Okay. So what I can say is every element that appears twice results in a XOR of 0. So as every element other than one element is appearing 2 times, so all of these elements would be resulting in an overall 0. Because if I just see, if I now know that two same elements give me XOR 0, give me an XOR of 0. Okay, so this gives me an XOR 0, and this would give me an XOR 0, and 0 XOR 0 is 0, so I would get 0. And if I do XOR with 1, I would simply get 1. Why? Because I just do this with 1. Okay, so 0 0 0 1 and 0 0 0 0. So it would be 1 and 0 would be 1, and all the others would be 0. So it would be resulting in the same number. Okay. So this was the observation. In this case. Okay. What I am simply doing is I just observe the truth table of XOR, and I can simply see that all the elements, the same elements give me an XOR 0, whereas any change would give me a 1, Okay. So I just use this strategy. So 2 to all the same elements would be resulting in an overall 0, and when this 0 would be XOR'd with the single non-zero element, that is occurring only single time, it would result in the same answer. Okay, I'll just do it with the test case that is given 2 to 1. 2, 2 and 1. I'll take my XOR initially as 0. Because 0 can result, if I just do XOR with this number, this would result in 2 only, because 0010 XOR with 0 would become 0010. Okay, so it would be the same number exactly. So I'll take XOR 0 currently, initially, and I'll iterate through all the numbers, making the XOR like at every position. So currently my X value is 0. Okay, I'll come at this position. I'll make the XOR. So X XOR 2. Okay, so it becomes 0 XOR 2, it becomes 2. Okay, my x is currently 2. I come at this position, so my would be x XOR 2. So 2 XOR 2, and I just saw that 2 XOR 2 is not none other than 0, none other than 0. So my XOR is again 0, my x value is again 0. I'll come to this point, I'll come to this point. Okay, I'll come to this point, and what I'll say is x XOR 1. So 0 XOR 1, what will result is 1. Okay, and I come to the last position. So this is what I have to return. This is what I have to return. 1. Is 1 the single element that is covering only one time? Yes, yes. So as we can see, we have got our answer. We have got our answer. We just made a simple observation. Just made a simple observation that the same elements occurring twice would give me an XOR of 0, and the single element would be the only element that would not result in an XOR 0. That would not result in an XOR 0. Okay, so XORing all numbers, if I put the same operation in all numbers, I'll get an overall 0, and when this overall 0 performs an operation with this 1, it would result in the same number. Okay, I'll just try two more test cases that are given. So 4 1 2 1 2. Okay, 4 1 2 1 2. Okay, my x is currently 0. X is currently 0. I come to this position, my x becomes XOR with this, so 0 XOR 4, it becomes 4. Okay, so my x is 4 currently. Okay, I'll move forward. I'll move to 1. I'll move to 1. So 4 XOR 1, 4 XOR 1, what it will become? What it will become? I'll just see. So 0 0 8 4 2 1 so 0 1 0 0 and 0 0 0 1. Okay, 0 0 0 1. So it will become 1, it will become 0, it will become 1, it will become 0. Okay, okay, I'll move forward. It becomes, it would 2 1, so it becomes 5. Okay, it becomes 5. Okay, okay, I'll just see, I'll just see. Okay, it becomes 5. Okay, I'll come at this position, I'll come at this position, I'll still do XOR. So 0 1 0 0 plus 0 0 1 0, it becomes what? It becomes 0 becomes 0, 1 becomes 1, 1 becomes 1, 1 becomes 1. Okay, so it becomes 7 at this point, 7 at this point. Okay, I'll just move forward, I'll just move forward. Okay, I'll again do it with 1 0 1 1 1 with 0 0 0 1. Okay, it will become 0, it will become 1, it will become 1, it will become 0 0 1 1 0, and I'll do it with 1, I'll do it with 2. Okay, so 0 1 1 0 plus XOR basically 0 0 1 0 0 0 1 0. What I'll get is 0 0 0 1 0 0 0 0 0 1 0 0. And if I try to decode it, what is it? 4. Yes, 8 4 2 1. Okay, following the 8 4 2 1 strategy, 8 4 2 1. Okay, so what I can see is 4 is my answer. Is 4 the only number that is appearing twice? That is appearing once? Yes, yes. So I'll return 4. Return 4. Why is this strategy working? Because if I take the overall XOR, this and this would become 0, this and this would become 0, and this would become 0. Okay, so anything XOR 0 XOR anything would become the same number. Okay, no matter how they are placed, no matter how they are placed. This technique is that's why working. Okay, if I try the third test case, that is only 1. So 0 XOR 1, that's become 1. Okay, so if I just try to code it, my x was 0 initially. What I'll try to do is I'll try to iterate through the array, and what I'll do in the process, I'll simply XOR it. I'll simply XOR all the numbers and I'll just return x. Okay. Okay, I'll try to submit. Submitted successfully. Okay. So if I just summarize what I did, I just made an observation. That when XOR is performed on the same elements, then the XOR becomes 0. So as every element is appearing twice, so the XOR would become overall 0, because like if 8 same elements are present, like 1 1 2 2 3 3, this all would result in an XOR 0. And there would be only one element that will be present only once. So 0 XOR 4 would be 4 only. Okay, so this is the technique I am following. If I just talk about the times and space complexity, as I'm running a single loop, I'm using a time complexity of O of n. And what is the space complexity? Am I using an extra space? No. So the space complexity becomes over fun, and that is what were supposed to do. You must implement the solution with a linear runtime complexity and using constant extra space. This was the overall solution to the question single number. I hope you guys like the intuition. I hope you guys like the observation. If you have any doubts, you can just ping it down in the comments. If you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.